Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, here we go. We're going to jump into the first lesson of chapter 4, 4.1.1. It's called multiple representations. And we are now going to go back to do a deeper dive into our tile figures. And we are going to spend this entire chapter looking at patterns, taking the data, putting it into tables, making a rule out of it, and drawing conclusions from the patterns that we've seen and from the rule that we've created. And we are going to start putting this data into into graphs, and just being able to go back and forth between problems that we have and these different representations, tables, graphs, and rules. Makes for a very powerful tool that you can use when you get into data analysis and problem solving. Okay, so let's take a look. It says in chapter 3, you studied different ways to represent patterns. You organized information in tables, you graphed the information about the patterns on coordinate grids, and you learned how to find rules that govern specific patterns. And we did that with our silent board game that we would play at the beginning of each period. Starting today and continuing throughout this chapter, you will find connections between different representations of the same pattern. You will also explore each representation in further depth. This work will develop efficient ways to go from one representation to another. By the end of this chapter, you will have a deeper understanding of many of the most powerful tools of algebra. Okay, so this is what we're going to do. There's a lot of work to do in this particular lesson, and normally you would be working in your groups, and each group would take one tile pattern and you'd have discussions about it, and you would create everything that you see here for each tile pattern. I'm going to do one for you, and then I'm going to allow you to choose from the other 4 which one you want to do. It's going to be a little bit tricky, and I just want you to do your best on it, okay? You're not going to be responsible for doing all of them. It would be good for you to watch me as I demonstrate how to do all 5 of these tile patterns. Because the more practice you get at this, the better you become and the easier it becomes to do these types of problems. And the deeper your understanding will be of the algebra involved. So you're going to take a look at a tile pattern, and let me actually show you one. So there's an example of a tile pattern. Here's problem B and problem C and problem D and problem E. Okay, so I'm going to do problem A, and you can do it along with me, and then you get to choose B, C, D, or E, the one that you would like to do on your own. And then I'll pause the video, and then you can work through it, and then you can watch me as I demonstrate how to do each one and see what the answers are. So you are given figures 1, 2, and 3, and what you need to do is figure out what the pattern is so you can draw figures 0, 4, and 5. Then I do not want you nobody wants you drawing figure 100. That would be ridiculous. But you can at least describe how figure 100 would look and how many tiles it would have. We're going to record this information in a table, and the directions, if you're looking at the online book, says to create a graph for it as well, but I'm going to skip that. Right now, we don't need to worry about graphing. Let's just focus on the patterns, creating a table, and then writing a rule for it, okay? So this part right here of creating a poster, we're not going to do that. You just do this work in your journal. All right, so here we go. I've got a table started on the left. You should copy down each one of these figures, 1, 2, and 3. Go ahead and pause the video and draw exactly what you see here in your journal. If you don't have graph paper in your journal, which I really hope you do, if you don't, do your best, okay? But try and make this look neat. If you do have graph paper, use the squares on your graph paper to make these as accurate and the same size as you possibly can. And if you use a straight edge and a pencil, that's going to be even better, because if you make a mistake, you can erase the pencil, and your straight edge will help get those as perfect as you can get them. Okay, so what I want you to do, copy these down and then count how many figures are in figure 1, how many tiles there are, how many tiles are in figure 2, and how many tiles are in figure 3. And I want you to set up a table for figures 0, 1, 2, 3, 4, 5, and 100. And I want you to record what you see here for the number of tiles for now figure 1, 2, and 3. Go ahead and pause. And when you're ready to unpause, after you've drawn those in and recorded those numbers of tiles, then we will move forward. All right, so figure 1 has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 tiles in it. Figure 2 has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 tiles in it. And figure 3 has 1, 2, 3, 4, 5, 10, 15, 20, 25, 26, 27, 28, 29, 30 tiles in it. So hopefully you got these numbers. If you miscalculated or miscounted, go ahead and change those right now. Now, what we've noticed in some of our tile figures is sometimes there's a constant growth rate. Like figure 2 has 4 more than figure 1, and figure 3 has 4 more than figure 2, and so figure 4 would have 4 more than figure 3. But that's not how this one is working. If you look at this, figure 2 has 8 more tiles than figure 1, and figure 3 has 10 more tiles than figure 2. So that is not what you would call a constant growth rate, right? You add 8 to it, you get this one. This one adds 10, you get this one. And I believe the pattern is going to be if you add 12, that would give you the amount in figure 4. And if you add 14 to figure 4's number of tiles, and blah, 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 blah. So this is a little trickier of a situation. The rule that we get here is not going to be a linear function. If we were to graph it, it would not be a straight line. It would be a curving line, or what we would call an exponential function. The thing about exponential functions is that they always have an x squared somewhere in the rule. And these tile figures are a perfect way to represent an x squared, because what we end up looking for when we see that there is not a constant growth rate is that there's going to be some figure in the tile figure that is a perfect square. And you notice I can see that perfect square right here. There's a 3 by 3 square. Here's a 4 by 4 square. And here is a 5 by 5 square. So what I want you to now do is look at these patterns of growth. If every time it increased, or the amount of increase was 2 more than the previous amount of increase, let's see if we can predict how many tiles would be in the 0 figure, the 4th, and the 5th. And we're not even going to go to the 100th right now. So if this one had 12 and you added 8 to it to get 20, then I believe you would have to add 6 to it, to the 0 figure, to get the first one. So how many tiles do you believe are going to be in the 0 figure? I think it's going to be 6. Because you add 6 to 6, you get 12. You add 8 to 12, you get 20. You add 10 to 20, and you get 30. And if you add 12 to 30, that means we're probably going to have 42 tiles in the next one. And when you add 14 to the next one, you would get 56 tiles. Now, I'm going to go ahead and erase these guys. Notice I was looking for pattern, and I apologize for that 10 right there. It's the worst 10 I've ever drawn in my life. I'll try and do better. All right, so now describing the different parts. How are we going to figure out this rule that applies to this situation? And how are we going to know how to draw the 0 figure, the 4th figure, and the 5th figure? Well, this is what I do. I break it down into parts. And this one appears to have 3 clear parts. There's a top, there is a square in the middle, and there is a bottom. So what I want to do is I want to come up with some sort of a linear pattern here that will tell me how many tiles go in each one of those sections for each one of these. So for instance, the top, every one of them always has 1 tile. It never changes. It's right here, it's right here, it's right here. taking a look at the square that's in the middle, how does that relate to the figure number? This is a 3 by 3, and the figure number was 1. This is a 4 by 4, and the figure number was 2. This is a 5 by 5, and the figure number was 3. What I'm noticing here is that the side length of these squares is always 2 more than the figure number. So I'm going to write that as x plus 2 because we're going to let the figure numbers always be our x, and the number of tiles will always be our y. So now, it is a square, right? So we're not just saying that there are 3 tiles in this square, 4 tiles in this square, and 5 tiles in this square. We're actually taking the number of units on the side and we're squaring it. So that would be x plus 2 squared. So this is 3 squared is 9. This is 4 squared, that is 16. And this is 5 squared, this is 25. So we've got the top now accounted for. We've got a square accounted for. And now the bottom. This is 2 for figure 1. This is 3 for figure 2. This is 4 for figure 3. So how do we relate the number of tiles in the bottom to the figure number? Well, it's always 1 more than the figure number, correct? So the bottom is going to be x plus 1. So for our rule for this situation, y is always going to be equal to 1, that's the top, plus x plus 2 squared, that's the square, and plus x plus 1, this is the bottom. Now we can combine like terms. There's some work that we can do here to make that a cleaned up expression, but let's not worry about that right now. We'll just keep it like this. That'll be the rule that we can declare. It's not simplified. I suppose you could call it x plus 2 squared plus x plus 2 if you wanted to, but let's just leave it like this. That's totally fine. So once again, you've got the top, you got the square, and you've got the bottom. So let's take a look at what figure 0 would look like. Figure 0 should have 1 on the top, correct? The square, what is 0 plus 2? It's 2. So it should have a 4 by 4 square in the middle, and the figure, or the bottom part's supposed to be a 0 plus 1, so you should have 1 on the bottom. So that is what figure 0 should look like. And how many tiles are there in figure 0? There's a total of 6, correct? And what did we think was going to be there? We thought it was going to be 6. So we, I believe, are on the right track by looking at the patterns for each one of those sections and then applying that to the figure 0. Okay, I'm going to go ahead and reveal figures 4 and 5 now, and we're going to see how that relates to our rule. Starting with figure 4. Remember, the top always has 1. The square in the middle has to have side lengths that are 2 more than the figure. So if our figure is 4, it should be a 6 by 6 square with a total of 36 of them in there. And across the bottom should be a row that has 1 more tile than our figure number. So this has 5. So we should have a total of 36, 37, 38, 39, 40, 41, 42, which matches what our prediction was for the table. And now figure 5 has 1 on the top. Square should be 7 by 7 since our side lengths have to be 2 more than our figure number. And so that would be a 49 tile square. And then across the bottom should be 5 plus 1 is 6. So 1, 2, 3, 4, 5, 6. So we're going to have 49, 50, 51, 52, 53, 54, 55, 56 is our total. All right. So now let's use our rule and see if we can answer the last part. How many tiles are going to be in the 100th figure? Well, in order to do that, we have to take this rule and we're going to say y is going to be equal to 1 plus, it has to be 102 squared. So we're going to take that and make it 102 squared plus 100 plus 1 is 101. Let's pull out our calculator. We have 102. Let's square that number to give us 10,404. I'll write this here, 10,404. Now you see why we're not doing the hundredth figure. Plus 101 plus 1. So y is going to be equal to 10,506 tiles. 10,506 tiles will be in the hundredth figure. So the last direction did tell us to describe what this figure would look like. So, 100th figure will have a single tile on the top. There's the one tile on the top. It'll have a square in the middle that's 102 by 102, right? That's your 102 squared for 10,404 tiles. And then at the bottom will be one more than the figure number, so the bottom would have 101 tiles for a total of 10,506 tiles. All right, so that's quite a bit of work there, right? What I would like for you to do is I would like for you to choose, and you're going to have to go to the book to do this. Or I suppose I'll slowly scan through all of these, and you can just pause the video with the number that you want to work with. Choose to do B, C, D, or E on your own and see how far you can go with it. It would be really, really impressive if you could get all the way through all of them. Create a rule, figure out what figures 0, 4, and 5 have the correct number of tiles in your table, and have a valid description of what this figure would look like. And I'll tell you right now, if you want to do the table at the end, after you've drawn the figures, you can do that. That's not a problem. I just like the idea of predicting what would be there based on the pattern that I see, and then verifying it once you've drawn the figure that your prediction and your figure that you've drawn match perfectly. Okay, so if you want to do number, or I should say B, then pause the video right now. Notice how there is a top, there's a square in the middle, and there's a bottom. Okay, so you can do B if you wanted to. You can do C. It looks like there's a top, there's a square in the middle, and a bottom at the bottom. I kind of thought that looked like a tail. Okay, so you can do this one. This one has a top. This one has 4 parts. It looks like you got a top, you got a square in the middle, you got something on the right side, and you got a little tail at the bottom. So I'm going to predict nobody's going to do D. You know, if someone wants to take a chance at it, see how well they do, go for it. And then E is another fun one where you've got a top, you've got a square in the middle, and I call those wings on the side. You got the wings on the left and on the right that match each other. So you decide which one of those you want to do. Pause the video on it so you can draw these and count accurately. And then when you're ready and you've got everything done, unpause and watch me work through the rest of them. And I'm going to spend less time working through the rest of them. I'm just going to show you how I came up with my rule. I'm going to fill in the tables, and I'm going to show you the figure numbers. Okay, so I'm going to pause and finish my work. You get to work on your own. All right, let's take a look and see what we got. If as we go through these, depending on which one you chose to do, this is really what I want you to focus on. I want to see if your table is correct, at least up to the 5th figure, and if you got these figures drawn and you can see the patterns of growth so that you could add on to it for the 4th and 5th figures and work your way backwards to figure 0. If you were not able to come up with a 100th figure, I'm totally okay with that right now. Working on your own on this is very, very challenging. Working in a group is often very, very challenging as well when you got 3 or 4 people trying to figure it out, much less one. And if you were not able to come up with the rule, that is absolutely forgivable as well, because this is complicated. But you are going to get better at it. Now, what makes this particular lesson tricky is the fact that every one of these rules involves squaring something. and that's really not a focus of 8th grade math. You'll find it's a lot easier when we are working with linear rules instead of these quadratic or non-linear types of rules that we've got for this particular lesson. So let's get to it. I'm going to rush through this. The top in all of these figures appears to have 2 more tiles than the figure number, right? This is 1 plus 2, 2 plus 2, 3 plus 2. Squares always have side lengths that are 1 more than the figure number. So this is a 2 by 2, that's a 3 by 3, that's a 4 by 4. So you take the figure number plus 1 and square it, and the bottom is always 3 more than the figure number, so x plus 3. So this is what the rule would look like. And we would use that rule specifically to figure out the 100th figure. So let's look at the top. Figure 0 would have 2 more in the top row than the figure number, so that will have 2. 0 plus 1 is 1, so that's going to be a 1 square, and then the bottom has to be 3 more than 0, which is 3, for a total of 6 tiles. The 4th figure would have 6 across the top, would have a 5 by 5 square, and 7 across the bottom, for a total of 38 tiles. And figure 5 is going to have 7 across the top, 6 by 6 square, and then a total of 8 tiles across the bottom, for a total of 51 tiles. By the time you plug 100 into our rule, you've got your 100 plus 2 plus your 101 squared plus your 100 plus 3. That eventually, once you use order of operations, gives you a total of 10,406 tiles. So the 100th figure would have 102 tiles across the top, would have a square in the middle that's 101 by 101, and the bottom row would have 103 tiles, for a total of 10,406 tiles. Part C. Looks like across the top, if you double the figure number and then add 1, that gives you the number of tiles in that row. So we'll call that 2x plus 1, where x represents the figure number. The square in the middle is always has a side length 1 more than the figure number, so that's going to be another x plus 1 squared. And then the tail always has 2. So this is what that rule would look like. You're adding all of these tiles together. Figure 0 is going to have 2 times 0 plus 1. There's 1 on the top. Square is going to be a single 1, since 0 plus 1 is 1, and 1 squared is 1. And you've got your tail with 2 on the bottom, so you'd have a total of 4 tiles in figure 0. Double the number 4 plus 1 would give you 9 across the top, would give you a 5 by 5 square in the middle, and a tail of 2 on the bottom. And then figure 5 would be 10 plus 1, plus a 6 by 6 square, plus 2 on the bottom, for a total of 49 tiles. The 100th figure would have 10,404 tiles, because you'd have the top row would be 201 tiles, right? 2 times 100 plus 1. The middle would be 101 by 101 for 10,201, and then you have your 2 tiles on the bottom for the tail, for a total of 10,404. For D, we've got 4 sections here. You've got the top, which is always equal to the figure number. This has 1, this has 2, this has 3. You've got the square in the middle that is always a side length that's 2 more than the figure number. And then you've got on the right side, this column is always 1 more than the figure number. And then the tail at the bottom always has 1. So here's how the rule would look. And then figure 0 isn't going to have a hat on the top because it's 0, right? There's nothing on the top. The square would be a 2 by 2 because 2 plus 0 is 2. On the right, this is 1 more than 2, and the tail always has 1, so that has a total of 6 tiles in it. Figure 4 would have 4 on the top, would have a square that is 6 by 6. You'd have a column that is 5, and a tail that is 1, for a total of 46 tiles. And then figure 5 would have 5 across the top, a 7 by 7 square in the middle, a column of 6, and a tail of 1, for a total of 61 tiles. Okay, so if we look and see how would this 100th figure look, the 100th figure across the top row would have 100 tiles. The square in the middle would be 102 by 102 for 1,000 or 10,404, and then you'd have a column on the right that would have one more than 100, so that'd be 101 tiles, and then you got the tail, that is 1. And so I did some combining. You'd end up with 10,606. I added 100, the 101, and the 1 to give me 202, and then added it to the 10,404 for 10,606. All right, so what do I want you to take from this particular? Oh no, we got one more. We got the E with the wings. I'm not ready to talk about the takeaways. All right, so your wings, well, no, let's start with the top. Is always equal to the, no, it's not. It's always 1, isn't it? I don't know why I'm rushing here. Slow down. Okay, you got 1 on the top. Your square always has a side length that's 1 more than the figure number. And then the wings, there's 2 of them. And the wings, each one is 1 more than the figure number. So I wrote it as 2 times x plus 1 here, but you could use distributive property and call it 2x plus 2 if you wanted to. So you, for both wings, you pull the figure number and add 2. So figure 0 is going to have the 1 on the top, the 1 square in the middle, and then 2 times 0 is 0, but then you add 1 to each wing, so you've got a total of 1 on each wing for a total of 4 tiles total. Figure 4 has the 1 on the top, has a 5 by 5 square in the middle, and then 2 wings that are each 5, or 2 of them that are, yeah, 2 of them are each 5, because it's 4 plus 1 is 5, for a total of 36 tiles. And figure 5 has the 1 on the top, it has a 6 by 6 in the middle, and then each one of the wings is 1 more than 5, so 2 wings of 6 tiles each for a total of 49. So what does the final 100 figure look like? Well, you'd have the single tile on the top. The square in the middle would be 1 more than 100 the side length, so that would be, what happened here? So that would be a 101 by 101 square in the middle, and then the wings would each have 101 tiles for a total of 202 tiles. So 1 plus 10,201 plus 202 means the 100th figure would have 10,404 tiles. All right, so what I was going to say at the end of the last set of tile figures, but I'll say it now because we're at the end, is that this is all about looking for patterns. It's you being able to break the problem into parts, understand the relationships between each one of the parts, and then make your calculations based on your new figure number or whatever changes are taking place within the problem, and then declaring your answer with evidence. Okay, so we've got how many different representations here? Remember, the title of this was called multiple representations. We've got the tile figure, which is like a visual representation. That's kind of like the problem that we're being asked to solve. We've got the table, which takes our data and puts it in an organized sort of a fashion. We've got a rule that can be used to define the entire situation and will allow us to find any figure number that we want once we've got the rule. And last representation, which I did not have you do, was a graph. And that we're going to start working on a little bit more in the next few lessons and will be a major part of Chapter 4. All 4 representations, being able to go back and forth between them, is critical for your problem-solving skills using algebra. Okay? All right, so good job. Hopefully this was making sense. If it's not making sense to you, we will continue working through this, and eventually if you give your best effort and you ask questions when you don't understand something, you will have this figured out by the time we end this chapter. All right, take care and on to your homework. Bye.
Hey, feeling